Hello friends, welcome back to my channel. So I would be starting a new series of videos where I would be naming the video as like an interview preparation. The reason is I would be just trying to speak what the knowledge I have related with the question and answers, and with the video the objective is to get an improvement and help out, and just to also highlight the phase how our mind works out. So in this first video, these I have a list of topics, or basically like the questionnaires which are like most common for any role from beginner to an advanced related with Oracle database administration. So these are like quite normal in a sense, like if you take from 11G till 19C, these are the basic concepts which has remained intrinsic or like consistent across the version of the database. Okay. So I think the first question very much, what is the SGA? So SGA stands for System Global Area. Okay. So what does it contain? It contains buffer cache. It contains shared pool. It contains result cache. It contains all other components. Okay. So I want to reiterate again that I'm just speaking what I'm remembering as from the interview perspective, and the objective is to get it improved as we move. Okay. So it is an important area which has the runtime information at the station and the system level, and it plays an important part in terms of its sizing based on the load. If the load is high, it means like the incoming SQL's transactions are high and your SGA is small, it can create a problem. Okay. Now the second is explain simple select query. So what does it mean? Like what happens from a single when I connect to a database using a SQL developer, and then I get the return result back. Okay, so simply what happens that you log in, your database is running on a port number 1521. Okay, you have your server IP address, you have your user ID and password, you connect as a SQL developer, you establish your connection, and then you type select asterisk from tab. Okay, so once your connection is established, so the first thing is that you send a request to the database based on the listener running on the port number 1521. Once the connection is authenticated, your existing connections is transferred to PGA. Now, your connection could be of a type dedicated or shared. Okay. Now the next time till the time you haven't closed your connections, listener does not play any further part because now you're directly connected to the PGA. And from PGA, okay, so the first thing is like your PGA will have your connection details. Then your queries will be checked in the SGA in the library cache, that whether this particular query has been used before you. If it is yes, it goes as a soft pass, and then that hash value is being picked from library cache. The query is being made and the results are being returned. If not, the query is hard passed and entry is put in the library cache, then the query is executed and it is returned. Okay. The second is asynchronous IO. So there is a two things, synchronous and asynchronous IO. So the way to understand is that if I'm sending a transaction from source to destination, if asynchronous IO is enabled, I do not have the to wait for the second transactions to go or to follow before like the first transaction reach to the destination. So basically it means like if my transactions request or response or any transaction I'm sending via an asynchronous IO, the handshake does not happen with the source. Okay. So then another is file system IO options. Okay. So one of the options it has tell, and I'm not able to recall to be very frank, but so let me reiterate, yeah, so I'm not able to recall. So these are all based on my memory and experience, what I'm able to recall. It is about that how IO works for my file systems which are being used, like the data files will be stored in some file system. Do I want to go asynchronous IO, or do you want to I want to go synchronous IO? So these options are controlled by file system options. Buffer cache limits. So what is a buffer cache? It is a part of SGA inside a shared pool where the copy of data blocks which are retrieved from the disk are being kept in the memory, so that the next time, if a, and there is a timeline, based on which it is being kept. So the next time when some other query tries to look the same copy or the frequently accessed copy, do not have to go onto the disk, and they can look back in the buffer itself. Okay. Now, dedicated server architecture. So in a dedicated server architecture, your connections, or basically UGA, which is like user global area, are a part of PGA. Okay. Where if there are like 100, if the database is configured to work as a dedicated server architecture, 100 users will have their user global area in the PGA. Okay. And then they will communicate with SGA. Okay. Where in the shared servers architecture, your UGA becomes a part of the SGA and your PGA is just left like that way. DBWR, which is called database, DB is for stand for database, W for writer. So this is the DBWR, is the database writer process. What it does, it writes the dirty buffers, like the buffers which has been changed from the memory to the disk. Log writer, it writes the redo log files. It writes the blocks of redo log buffer onto the redo log file, and those are being written to the archive log file. Yeah. So from redo log file to archive log file, this is being done by ARCH process. RVWR, I'm not able to recall. What are the different types of table? So based on my memory, it is a heap organized, index organized. Heap organized is the default one, and another is the index organized. I do not remember the detail. What are the different types of index? B-tree index, bitmap index, clustered index. I'm not able to recall. Okay. Explain plan. Okay. So what is explain plan? So before a query is executed based on set of access, its plan needs to be defined by optimizer, and then the optimizer defines its based on the stats collected at optimizer label. Now there are three ways. The first is the query has not executed, query has executed, and that the query has executed long back. So the first step, the query has not been executed. If I put set auto trace on and I put explain plan for select asterisk from tab, it will say explained. Then I can write select asterisk from table bracket dbms underscore explan dot display. What it does, it will give the optimum plan which optimizer has thought that if you would have actually run select asterisk from tab, what the path it would have taken. Okay. Now this is the part one. Okay. Now let's say you already ran it, select asterisk from tab. This has run and the result has been returned. Okay. So in order to see that SQL ID, in order to see the explain plan for the SQL which has already been ran, you have to write select. You have to actually find the SQL ID first. Then you have to do select asterisk from table dbms underscore explan dot display underscore cursor, and then you have to put the SQL ID. I'm not able to recall the exact syntax. Same way, if the query has run a long back and my AWR retention period is 10 days, and I wanted to look for some query which has run long back, I get a SQL ID from $SQL, okay, or $SQL area. Okay, so there is a difference in $SQL and $SQL area. $SQL area contains the information about the parent. $SQL contains information about the child. What does it mean? It means I have a two different user connected through two different IDs. They ran the same query with a similar naming convention, similar syntax, I mean a similar fonts. There is no change, but these are being returned, being yeah, these are being ran with a different user ID. So their plan has value will be same, and how do I find that? I find it by querying $SQL. Okay, so I have to query $SQL area or $SQL, okay, to find my SQL ID, and then I can run db select asterisk from table bracket dbms underscore explain dot display, and then I'm not able to recall it. Okay, now come the tracing. So the tracing is an old method in which we try to trace a particular set of execution, and there are different tracing number which is like 10046, 10056, and then if I put label 12, it will give me detail about execute, parse, and fetch details, and also an OPI call. So there are different trace label. We can run it, and then whatever we run, let's say I run select asterisk from tab and I get a query. So I have an explain plan through which I know what my set of sequences are, in which order this explain plan ran. But the tracing part, what it does, it will give you the behind the scene, basically what happened at the OS level. What the more detail I needed, it will give me each and exact in the trace file. Okay, so there are different way you can trace. You can trace a session, you can trace a module, you can trace a application. Okay, now different dynamic performance view. So there are different dynamic performance view. What means by dynamic? Dynamic means that these views gets populated the time instance are running, and there are values coming. So what, so we have actually like, we need stats at the system level, we need the stats at the session level. So we have v dollar sysstat, which contains system statistics. We have v dollar sesstat, which contains session statistics. We have v dollar session, which contains details about active and inactive session. We have v dollar process, which contains detail about the tracing file. Okay, so these are, then we have a v dollar session underscore weight, which contains the current weight of the session. Okay, detail about the session weights. Okay, now we have AWR, ADDM, ASH report. So what is AWR? AWR stands for automatic workload repository. ADDM stands for automatic database diagnostic monitor. ASH stands for automatic sample history. Okay, auto sample history, I think so. So what is AWR? So AWR report contains detail about the instance based on the number of days of the snapshot that have been fixed, let's say 10 days. So it will have a details about the stats of the system in the AWR repository, and then we can generate AWR report, and this gives the details about foreground, background, weights, latch, redo log file, database wait events, and all those things. ADDM is the automatic database diagnostic monitor. So when we run this report for certain intervals, this queries the AWR repository in the backend and give us the standard report, based on which if we modify, we can improve the performance of the database. ASH report gives us the activity happening per minute. So we can just go to the minute level detail if we want, and we can also generate ASH report in if the session is currently not active, and if we put the the previous timeline, it will query $active session history table and give us the detail for a 1 minute intervals. But for AWR, we have to stick to, in general, 30 minutes or at minimum 15 minutes of duration. Okay, but ASH can give us minute by minute data. So which is more useful? Basic of optimizer. So what is an optimizer? See, optimizer is, I'm not able to recall, but let me say some theory on it. So you have a data dictionary and I collect a stats. So what I'm actually doing, I'm trying to update the data dictionary, which is a part of the memory or tables, which is being accessed when the SQLs are being executed. Before execution and before getting the plan formed, the data dictionary is being accessed, and the optimizer is the one who does all these activity. And optimizer consults data dictionary to get the latest detail about the table or schema and object based on what are the number of the values last time when it was analyzed, is there any update, delete and insert. So instead of optimizer directly going to the table fetching those records, it just read the stats which was last gathered and stored, and then generates an optimum plan. Okay, histogram. So what is the histogram? So histogram is a type of stats gathering in which if the number of the unique values are less than 256, we form number of buckets based on the unique values. So for an example, if I have a two user, let's say sys and system, and I have a 900 values for system, 100 values for sys, and out of those 100 values, my top 50 values are in the row ID 1 to 50, and my rest 100 values are from the row ID 900 to 950, and I want to extract the result, select asterisk from ABC where my username is equal to sys, and let's say my histograms has not been calculated, histogram stats. So in this case, what will happen, that the query, the optimizer will go for a full table scan because it has no idea, in a sense, how many values for sys are there. Okay, let's say I gather the histogram stats. In this case, the optimizer knows, okay, so sys has total of 100 values from row number 1 to 50. It has the first 50, and from row number 900 to 950, it has another set of 50 values. Okay, so if my histogram stats are calculated, it will not go for full table scan. If my index is there, it will use that index and use the histogram stats to generate a more optimum plan with the low cost. Okay, what is the bind picking? So I'm not able to recall, but let me try to recall. Okay, so what happened, the bind picking is related with the bind variable. If I have a query in which I am using a bind variable, okay, and I'm getting one plan at my first run, in the second my adaptive optimizer underscore adaptive underscore statics is enabled, okay, my database, while executing second time, finds that for this particular wind value, not the one for which I ran it, this execution is optimum. Okay, so this is called wind picking. Now adaptive cursor sharing. Okay, so what is the cursor? Cursor is a memory area. So in that, and that is a part of the shared pool inside a library cache, and this holds the hash value for the parse SQL. Now it is adaptive cursor sharing. So what happens with this feature enabled? When I run explain plan for select asterisk from tab, it gathers some, it generate the optimizer generated an execution plan based on the stats which is already there in the data dictionary. Now with the adaptive cursor sharing feature, when it and okay, it generated, and then we found that my estimated values is less than the actual values, or either my estimated value is more than the actual values. So it means the plan which was generated by the optimizer in first place is not optimum. Okay, so the next time when this feature is enabled and this query gets to know, it will generate in a runtime better plan based on the last run. My definition might not be correct, but similar to this. Okay, wind aware cursor. So basically this is the filled in $v SQL area where we can find where my SQL ID is bind aware or not. Okay, and I'm not able to recall properly. Okay, so what is the full table scan? It means you're scanning the table fully from 1 to 100 or 1 to million. Row ID scan, scanning of the table based on the row ID. Index scan, scanning of the table based on index. Cluster access, I don't know. Hash access, I don't know. And sample table scan, I don't know. To verify, I'm not able to recall to even to speak. Hints, what are the hints? So sometime Oracle has certain hints, and I think these are like 255 in numbers, which we can provide exclusively in our query to make the query processing fast. Okay, so this is the use of it. And how do you do it? You put it select or maybe anything update, and after that first keyword you put it backslash plus asterisk plus, and then you put the hint name comma, and let's say you put 2-3 hints name, so it will follow from left to right. Okay, cursor sharing. So there are this is a database parameter. It has an exact, force, and I think there is one more. So what does it mean? That if this parameter is set to exact, then my cursor will be shared. That means if my SQL queries are same in two different session or two different user ID, and if it is meant exact, no parsing will be done, and whatever the hash value currently to that SQL user is present will be used. And then force is that you forced to share it, but I'm not able to recall the exact definition. Okay, db block multi-block. Okay, db underscore multi-block read count. So this determines when the db file scattered read is performed. So this value tells at the same time Oracle process can read how many blocks. If I put let's say 200, it will read 200 blocks. It has a capacity to read 200 blocks, you know. So this determines the number of the blocks that can be read while we are performing db file scattered read. Okay, optimizer index caching. I don't know the exact definition, but what it says that optimizer, if it is enabled, optimizer can cache the index part. Optimizer index cost adjustment. Okay, so I know this value. So the default is like 100. If I put lower than this, it just gives the probability to the optimizer whether to look for an optimizer whether to look for an access path based on the index uses in an explain plan. Okay, so if I put 20, it means I have reduced the probability, so it will be whatever the number of the samples it does to identify an optimum plan. If it is set to 20, so it is like 20%. Okay, not 100%. So most of the time, 80% of the time, it will not look for any explain plan, or it will not suggest any explainer based on index, right? So it goes like that way. Optimizer mode, I think the optimizer mode has 3 values, which is like all underscore rows, first underscore rows is underscore n, first underscore rows. Okay, these are the 3 modes of optimizer, and I do not know the exact definition, so I'll just move out from here. And then PGA aggregate target. So what is this value? And there is a PGA aggregate limit. Okay. So the difference is that PGA aggregate limit defines the maximum PGA the database can have. The PGA aggregate target value defines what is currently active. Start transformation enabled. So this value is more for data warehouse if it is yes. And I don't know the definition for it. Okay. SQL tuning advisor. So you have to understand this particular feature advise you on the tuning aspect of the SQL. So for this to work, you need to create a SQL tuning task. In that, once the task is created, you need to define what are the SQLs that this feature has to analyze. So once you analyze, once you give the details of that SQLs which needs to be analyzed, and then you click it submit, it will analyze it and it will give you the result. Say that hey, you should gather stats twice a day. You should have an index, and then your clustering factor is not good, something like this. So it will give you. Okay. So this is the use of SQL tuning advisor. SQL access advisor. This will give. I'm not able to recall exactly, but it will help in deciding that if you use some hints or something, you can alter the explain plan access path. Okay. So instead of a nested loop, you can go to the hash join or vice versa. Okay. So okay, now this is recursive calls, db block gets. So these are the part of explain plan. Okay. It comes when you put set auto trace on, then you put explain plan for select asterisk from tab, then you do select asterisk from table dot a bracket dvms underscore explain plan dot display. Okay, so you get these detail. What are the recursive calls? Okay, what are the db block gates? What is the consistent gates? What is the physical reads, redo size? Okay, just let me try to answer recursive calls. Okay, so recursive calls means that 123 recursive call has to be done in order to get the result. So it means from the client to the database, there were total of 123 round trip happened. Two db block gets. Okay, so the two rows has to be retrieved from the disk. 826 consistent gets. It means 826 datas blocks were able to be read from buffer or memory. 643 physical reads. It means 643 blocks were to be read from the disk. And there is a difference in db block gets and physical reads. So this whole operation generated 0 bytes of redo, and total of 27758 bytes was sent from SQLnet to client. Okay, so application to the database. Okay, 105 received via SQLnet from client. Okay, so it means from database 27758 bytes was sent to the client, and out of that 105757 bytes were received at the client side. 60 SQL round trip were done from clients to and from client, 60 total. So 123 recursive call, still the first line is not clear to me. 5 sort memories were done, 5 sortings were done, that were all done in a memory. 0 sortings were done in disk, and 876 rows were processed total. So it returned 876 rows. Now let's see, can I add some values to get 876? So if I get 826, so which is like 7 to 50. Okay, so if I do subtract, okay, so I'm not able to. Okay, SQL plan baselines. Okay, now what happened that when my query is being run and SPM is enabled and my query is being run, very first time it get passed and its hash plan values get stored. With the time, with so many features being enabled like adaptive cursor sharing and all, so these features gives an ability to the optimizer to decide an optimal plan based on the stats. Okay, and these can also be gathered based on the estimated and actual rows returned. So the optimizer decides, hey, these there is a better optimal plan, so we should be using it. So what it does, it creates another plan and assign it as a hash plan value. Okay, with the SQL plan baselines, we can enable, or we can manually enable, we can actually enable the best plan which the optimizer uses anytime. Okay, when optimizer is generating the multiple plans based on the stats change, we can fix one plan as the baseline plan that optimizer has to use, and we can just either delete or remove those plan hash values from the library cache, or we can just let it go. So what are the different types of joins? um I think it's like a hash join, nested loop joins, and I'm not able to recall. Okay, so then you have a partitioning. So you have a composite range partitioning. So basically what it means, that you're doing the first partition on a range 1 to 5, then inside that you're again doing a further partitioning based on 1 to 5. Second is composite range hash partitioning. The first partitioning you have done based on 1 to 5, then on the you have done the another partitioning inside it based on the hash value. Composite range list partitioning. So you have done first partitioning 1 to 5 based on range, then inside that you have listed Monday, Tuesday, Wednesday as this thing. Composite list range partitioning. So in this first partitioning is based on the date or a month, the second is done based on the number 1 to 5. Composite list hash partitioning. So the first partitioning is done based on the list, which is like month or date, and the second partitioning inside this has been done based on the number. Composite list partitioning. So the first partitioning is done on the based on the month and date, and then you further do inside it based on the month and date. Star schema design. So what it does, you have one table in between. For an example, let's say it has 5 rows or 5 columns. Okay, then so let's say another way. You have a 4 tables. Each of these table has one column, and each of these column is the primary key of that particular table. Okay, now you created a 5th table in which its first 4 columns are respectively the foreign key for all these 4 tables, and the 5th column is its own column. So if you put it into a piece of paper, so you see, if I put that 5th table in between, then I can make a star like structure in which its first 4 column would be pointing to the primary key of other 4 tables. So this particular setup is called star schema design. Types of indexes is like B tree, bitmap. I'm not able to further recall. Database buffer cache. So database buffer cache is the place where data from the disk are being copied in the memory. Redo log buffer. This is the redo log buffer in the SGA where the changed data copies are being kept. Shared pool. It has a library cache, dictionary cache, result cache, shared areas. So shared pool is a piece of memory in which you have a library cache which contains the plan hash value of the SQL, dictionary cache which contains the detail about the data dictionary, result cache, it contains, we can use this result cache to keep the frequently accessed return in the result cache. So in this way it will reduce our processing time. Shared areas, it can be used for other processing. Okay, large pool, I'm not able to recall. RAD is redundant array of independent disk. So in this technologies we multiplex the disk. So it is a RAD 0, RAD 1, RAD 5, and so on. So the most frequent is RAD 5. Multi-block read. So this process means that it is used for DB file scattered read, and in this we are using multiple blocks on the disk. or maybe on the memory area. Direct path read, it means my Oracle processes, instead of going to the memory, is directly reading from the disk. Direct path writes, in this what happens, instead of changing the data onto the memory buffer, my Oracle process is directly writing the data into the disk. What is the difference between shared and dedicated? So in the shared one, my UGA, which is the user global area, is a part of SGA, whereas in my dedicated, UGA is a part of a PGA. What are the wait events? So the wait events can be defined as a phenomenon for any query which is being triggered to the database in order to return the result, is waiting for some resources, and these wait can be further classified on buffer busy waits. So buffer busy waits means that the process is not getting access to the memory blocks or buffer blocks in the memory in order to read, write, or for read and write. Free buffer bits, like the Oracle process is not getting access to any buffers blocks in the memory which is free. Okay, db file scattered read, it means the process is waiting for the multiple block read count at the disk level. So db file sequential read, it means that the process, the wait for db file sequential read, db file sequential read. So what this it mean, that this particular process is waiting for sequential read. It means, like, that this particular process is waiting while the Oracle process is doing a sequential read. NQ waits, it means that the Oracle process is not getting the proper NQ in order to uh, take control of the memory structure. Library cache wait, it means that the Oracle process is waiting to access library cache to check for the plan hash value. Log buffer space wait, it means the Oracle process is not able to get the space in redo log buffer, because at this time Oracle process has to wait so that the changes which has been done in the redo log buffer would be written to the archive log file sync. So this particular process means that the LGWR process is busy writing the changes to the archive log file, and it has to wait because the previous process has not completed. So what is the DNS server? It is a domain name server. This is used for generally VMware or anywhere in the world to resolve the scan IP, which is called single. It is used in rack cluster. We call it a scan IP. In order to resolve the name, DNS server is used. Okay, so friend, I think that's all I have a list for today, and I'll just gather the more. And as I say, like, the name of this video will be the preparation series, and I like the most of the answer that I will speak what I have remembered by myself, but those could not be correct or incorrect, or some topics needs more detailed explanations. So with the time, we'll try to develop a habit so that we are able to speak more concisely towards an interview perspective point of view, and this can help you, me, or both of us, or everybody of us, to be more resilient when we appear for any interview. So thank you, and see you in the next video.